Welcome back to Module 4, Understanding Network Security. If we recall in previous presentations, we again discussed security. In this particular module, we're going to be focusing our attention upon network security. Now, one of the devices that help us or assist us in this process or endeavor is a firewall. A firewall is a system that is designed to protect a computer or a network from network-based type of attacks. A firewall does this again by filtering the data packages that transfers your network. Now, when you think about the data that transfers our network, it's not all sent at one time. It's literally broken out into packages, and what happens, it reassembles itself on the other end. What the firewall does, the firewall is based on package filtering. And what that does, in essence, means it inspects the data packages as they attempt to transfer your firewall. Instead of analyzing each of those packages individually, you have called a circuit level, again, firewall. What that does, it monitors the TCPIP. Now, TCPIP stands for Transmission Control Protocol, Internet Protocol sessions, by monitoring again the TCP handshaking between the package to validate again the sessions. Now, when you think about TCP, TCP is a connection-oriented type protocol. In other words, what happens is whenever a message is sent, it receives some type of confirmation. Unlike the UDP, which is a non-connection oriented type protocol, there's no form of communication. Now, confirmation. Now, a good example of where UDP is used is, for example, in video conferencing, because you're not really concerned about losing a package here or there. Because why? Because packages are constantly being sent over the network. So again, TCP is a connection-oriented, while your UDP is a connectionless type protocol. In other words, that you don't receive any type of acknowledgement. Now, for its application-level firewalls, they're also known as Proxy Service. They work by performing what we call a deep inspection of the application data as it transfers to firewall. Rules are set based upon, again, analyzing the client requests and the application responses. Then what it does, it enforces the correct application type behavior. So again, the application performs what we call a deep inspection. Remember we mentioned about the package filtering. It does not necessarily do that. A deep, analysis of that packet. We also have a term called stateful multi-level firewalls. These particular firewalls are designed to provide the best features of both the package filtering and the application layer firewall. So basically what it's doing is borrowing the best from both of those particular type of firewalls, and as a result we come up with what we call a stateful multi-level type firewall. We also have a term called VLANs. Now, if you think about a VLAN, if you call, what device do you recall where you can actually configure a VLAN? If you're thinking along the lines of a switch, you're absolutely correct, because that's the only device you're able to set up what we call a VLAN, a virtual LAN, in other words. Now, VLANs were developed as an alternate solution to deploying multiple routers. VLANs are logical network segments that are used to create a separate broadcast domain, but still allow the device on a VLAN to communicate again at layer 2. Remember, a switch is a layer 2 type device without requiring a router. Then we have a term called intrusion detection systems. Now we're looking at, remember, this particular presentation of module is focusing upon, again, how we're able to go about the process of securing our network. Now, one way we can secure our network by employing IDSs, which stands for intrusion detection systems, as well as we have intrusion prevention systems. You may ask, what's the difference between the two? Obviously, there are some differences. For example, when you think about intrusion detection systems, they're designed to detect unauthorized activities, attacks, and network compromise. Intrusion prevention system is similar, again, except that in addition to detecting and alerting an ISP, or internet service provider, or you, perhaps if you're the administrator, it can also take some form of action to prevent a breach from occurring in the first place. You may ask, what method is that? Remember, these devices in themselves do not come out, get them out of the box, and they've already been pre-configured. Initially, what you have to do is set them up yourself. And perhaps you're going to set what we call initial baseline type setting. And obviously later on, you may find yourself needing to go back and tweak it here and there. Again, because why? Because the threats that you're dealing with or ones that you have to contend with are becoming much more sophisticated. And as a result of that, you may need to go back and tweak the changes or make some adjustments to that initial baseline settings on either an IDS or an intrusion prevention system. Now, one thing I want to also add about intrusion prevention system, what I mean by take action. For example, if it detects a DOS attack, an intrusion prevention system, you can have it pre-configured where it actually, when it detects an attack at a certain port, it shuts the port down. In other words, that's what I mean by taking some form of action. When it shuts that port down, guess what happened? The DOS attack ceased to exist because you literally it had been automated. That process had been automated to shut that port down. So the attack that was that individuals engage in no longer is going to impact you as an organization, particularly your infrastructure. Then we have a term called honeypots. Another way to think about a honeypot is considered a decoy. Now, that's one of the ways you're able to protect your network, because you're going to set up these what we call decoys. They're going to look like the real deal. And in fact, you're going to load it up with data, useless data. But unbeknownst to the would-be hacker, he thinking he or she had hit the mother load, because now they're able to hack into that system. They say, man, I hit the mother load. But the reality is they did not hit the mother load. They only hit a decoy. And what's happening is when they actually engaging in that process, you actually got process where you gathering information on them. And the purpose of gathering information on them is so later on, you can actually turn this information over again to our police or authorities, and they can actually pursue these individuals, and again, obviously, through some form of litigation. So again, we want to make sure that we have honeypots on our network. And one thing I also want to mention too, in regards to honeypot, now if you have an individual who is a seasoned hacker, he or she not necessarily going to fall for the typical honeypot. However, you have those individuals who are, I use the term hackers in trainings or attackers in training. They're not going to be as knowledgeable, and as a result, they're going to assume that they have actually infiltrated your main production network, and in fact, they did not. Only thing they have access is useless information. But again, you're using this as a platform with which to launch your own investigation of them, thereby able to again gather all this essential information so you can turn it over to your legal authorities as well. But again, honeypots and honeynets are padded cells are complementary type of technologies. In other words, that's one way to enhance your IDSs as well as your intrusion prevention system by employing what we call the process of setting up and configuring what we call honeypots. Now, a honeypot is a trap for a hacker. That's what it's all about. You're trying to trap that individual, and that's the goal. We also have a DMZ. Oftentimes, your DMZ is referred to as your perimeter network. It's used, again, to secure your host on a network segment. Now, one of the things I want to point out in regards to DMZ, like, for example, think about an organization like Amazon. Now, Amazon wants you to be able to access, again, their web browser. Now, they don't want you to access their database because that's not going to be a part of that. Because when you set up your database, that's one of the reasons I mentioned before that when you installing, say for example, either Active Directory or some other service on your server, you don't want it being able to perform both those functions or service at the same time. And the rationale for that is because what you're doing is increasing the attack surface of that particular server. And what we want to do as security professionals is not actually do that. What we want to do, for example, we're going to set up our web browser or web server out on our DMZ. Now, the database server, which again, that stores all our credit card information, is not going to be stored out there on the DMZ. It's going to be located in our main production network. And again, it would have some form of connection with the web server, but just because a person hacks into the web server does not mean they have access, again, to my database. That's one of the reasons that you want to make sure that you don't put your database out there on a DMZ. You want it to be on your main production network, away from that. Now, obviously, you want them to be able to access, again, your site like Amazon. That's what, therefore, you put your web browser out there, or again, in the DMZ or perimeter network for that purpose only. In most of the DMZs, the hosts on the DMZ are connected to behind a firewall. When we discussed the firewall earlier, And it's also connected to a public network like the internet as well. Then we have a network address translation. Now, this is a technique, again, because this technique was actually developed or employed because at some point in time, they were running out IP addresses for IP version 4. We'll be discussing IP version 4 again is a way, again, for example, now most computers nowadays are able to, again, be set up to utilize IP version 4 and 6 at the same time. But again, and what we saw happening during that time was they were running out of IP addresses. So they came up with this concept called set up what we call a network address translation. So basically what it is, it's a technique used to modify the network address information of a host while the traffic is traversing a router or a firewall. This particular technique is used to hide your network information of your private network while allowing traffic to be transferred across a public network like the internet. So again, that's one of the things when you think about NAT, network address translation, it's a way of hiding your internal configuration of your network. Because again, if a hacker knows exactly what you have behind that firewall and what devices, that makes it easier for them, because one of the things they may say, you know what, I wonder if they have the latest patch installed. I wonder if they have this and that. So again, we really want to make sure again that we employ all these various technology ranging from IDSs, IPSs, the honeypots, as well as the network address translation. All of these things in themselves are going to make our network that much more secure. Then we have a DNS Security Extension. What this does for us is add security provision to your DNS, domain name and services, so that the computers can verify that they have directed to a proper server. That's very important. A lot of times, that's why it's so important when you going on the internet and you go into various, checking your email, and you get an email telling you, hey, log on to your bank account. What happening is they're not actually, when you go to, it direct you to a site which is a fake site. It looks like the real deal. It looks like, for example, Bank America site, but in fact, it's not Bank America site. It's a fake site. You log on to it, and then for some reason not able to access them. You wonder what in the world going on. You know what just happened? You just provided them with your account information, your password, and so forth. Now what that person's going to turn around is go in your account and have access to your bank resources. So that's one of the reasons that we have to be very careful, very mindful that we don't arbitrarily go even on a web, even though we got this email, and just click on that link and go to and log on to our bank site. If you get an email message from your site, what I would advocate that you would do is you're never going to get that from the email anyway. But what I would always choose to do is always go to the bank site myself directly, not through no hyperlink, because that can get you in some trouble. Then we have a term called protocol spoofing, which again is the misuse of network protocols to perpetrate a host on a host or a network type device. Remember, you got all these individuals. We got a term called MACs. People can spoof your MAC address. Now the MAC address, remember, the MAC address is a unique number burned on your network interface card, and no two NIC cards have the same MAC address. So a lot of time what happened, they're able to spoof this through software and able to, again, spoof as if it's your computer, and in fact, it's not your computer. So again, we have to be very aware of this process. We have also a denial of service attack. Essentially what that does, it floods your network being attacked with overwhelming amount of traffic, shutting down your network infrastructure like a router or a firewall. So how in the world do these individuals able to accomplish this denial of service attack? What happens is they have what we call zombies. And a zombie, basically what has happened, a hacker has somehow gained control over your various devices, such as your iPad, your tablets, your iPhone. Unbeknownst to you, they're utilizing your device to launch attacks or send so many requests to a website to the extent it brings that website down. And so again, we have to be aware, because hackers will never use their own computers. They're going to use computers that they've already hijacked. They have access to these devices, and so they're able to launch these various attacks against various websites. And it floods those sites with all types of requests. Then we come to a term called a man-in-the-middle attack. Now, one of the ways that we're able to protect our network from a man-in-the-middle attack is by employing what we call a VPN. What we're starting to see nowadays, a lot of organizations have gone mobile. A lot of their employees are mobile. That means that they do not have an office space. They operate for the most part from home and on the road. But guess what? They still need access to the network. Now, one of the ways we can ensure that it have secure access to our network resources is by employing a technology called virtual private network. Now, a virtual private network the purpose of it is to allow us to be able to communicate securely over an unsecure infrastructure, vis-a-vis being the internet. And so what happened is that VPN, it creates a virtual tunnel. And in fact, within that tunnel, we have end-to-end encryption. That means when we have end-to-end encryption, we mitigate or minimize the likelihood of someone engaging in what we call a man-in-the-middle attack. Now, this type of attack is where the attacker breaks into your communication between the endpoints of your network connection. Once that hacker has broken into the communication stream, he can intercept data being transferred or even inject false information into the data stream. So one of the ways we can protect ourselves and make sure we able to communicate securely. In fact, now you're starting to see a lot of organizations. I saw a commercial today where you're able to download a VPN to your iPhone, which is a great idea because you want to be able to communicate securely, particularly if you're going to your bank account site. You don't want someone engaging in a man-in-the-middle attack, intercepting information. And again, because the reality is this, the internet is an unsecure infrastructure. And we don't want our information definitely not going over in clear text. We also have a term called backdoor attacks. Now, these particular attacks are against an opening left in a functioning piece of software that allows access into the system of software application without the owner's knowledge. So a lot of times, even when you think about backdoors, when a hacker hacks into your system, what they're going to be doing is, because remember, the hacker does not want to be discovered. That's not their goal. They want to be able to continue to conduct their processes or their mission unfeathered. In other words, you're not even aware that they're there. But again, what hackers going to do is they're going to create these backdoors within your systems. And the purpose is they're able to get in, enter in, do what they need to do, and actually exit your network unfeathered. And so again, a backdoor attack is oftentimes can be launched as well against your system. If, for example, someone has hacked into your Exchange server and they create a backdoor, they can come in and out. For example, how can this impact you? One way it can impact you, for example, when you have an IDS, intrusion detection system. Because remember, the intrusion detection system, it only thing it does is alert us. It can alert us through what? Some form of email or maybe a text message. But guess what happens? If the hacker hacks into your system, if he or she can prevent that email from going out, guess what? You're never going to get that notification. And so again, remember, hackers do not want to be discovered. That's not their goal. That's not their endeavor. Then we come into a term called DNS poisoning, domain naming services poisoning. Again, this type of attack is an attack against the cache information on a DNS server. If you have a replay attack occurs, it's when an attacker is able to capture an intact data stream from your network using, again, some form of network sniffer. They can modify certain components of your data stream, and then they can replay that traffic back to the network to complete their attack. We have a term called a buffer overflow. Now, a buffer overflow basically is where a hacker, what he or she does, they exploit the poorly written code, injecting data into a viable field and then leveraging that response to access information in your application. That's why it's so important nowadays. In the past, with our programmers were not necessarily concerned about, again, security at that point in time, at that juncture. For the most part, they were concerned about, hey, I got my application working or the program working. But nowadays, we need to ensure that if we have programmers who are actually writing code for us, that they're actually engaged in what we call secure code practices. In other words, when you think about security, security should be an intricate part of that process. Security should never, ever be an afterthought. So when you're writing code, security should be part of that process, not an afterthought. Like a good example, for example, if I was hired by an organization and this, for example, I got this contract, say maybe millions of dollars to build a network for this particular company. Now, obviously, when I quote a price to them, they're going to figure everything is covered in that price. Would you agree? Now, let's imagine, for example, I quoted them a price of $2 million to build this phenomenal network for them. However, when I quoted them, I did not consider security at that point in time. Maybe I forgot to think about security. Only thing I was thinking about, hey, I'm going to get this network built for them and let's get it rolling. However, later on, I come back to that same company and say, hold on for a second. I know I quoted your price of $2 million. Now I need to quote your price of another $1 million for the security part. I'm pretty sure most organizations are not going to be happy when I come back and tell them, oh, you quoted me $2 million. Now you tell me I got to pay another $1 million. Again, I'm not going to get much business in the future if I was engaged in a practice like that. Therefore, we have to make sure that security is an intricate part of actually building our network from the onset. So when you quote someone a price, you want to make sure it includes the security. That's why the step back from this particular point, getting back to secure code. That's why you have the system development lifecycle now, where security is part of that process that a programmer must employ when they're actually, again, writing code. Because I don't know if many of you heard a term called SQL injection. That's where someone is able to inject code to your server, or say, for example, your website, and they say, for example, they're going to order 1,000 widgets, and they're able to somehow manipulate that. Now, where 1,000 widgets would cost them $1,000, I'm able to get them for $10. Because why? Because I was able to inject code into that system, because the programmer who written that code for that database, or let's say, for example, that web server, did not engage in secure code practice. As a result of that, again, guess what? I'm able to commit a crime. Now, you also have, I mentioned SQL injection. Attacks are one of the oldest attacks against your web application using a SQL Server database type application. That's why it's important that you engage in secure code practices. We also have wireless LAN. This allows users to connect to a network while LAN and remain mobile. I cannot say enough about, again, how technology has evolved nowadays, particularly with wireless technology. Now, a lot of time you may have some individuals who have different opinions regarding whether or not they say, is wireless much more secure than the wired type network? Obviously, there are a lot of different opinions regarding security. But nonetheless, what we want to make sure that, again, if we're going to set up some form of wireless technology, we want to make sure we exercise due diligence. In other words, doing everything reasonable to take that wireless network. And we're going to talk a little bit. I'm going to mention some of the things that you can do to secure your wireless network. Now, one of the things you can do, first of all, is change your SSID, your security set identifier. A good example would be if you went to the store and you purchased a Linksys router. Now, the actual SSID name for that router will be Linksys. You know what the password is going to be? Admin. Let's say hypothetically I failed to change the SSID, or I left it as it is. As a hacker, I'm going to assume maybe if he didn't change that, then maybe he didn't change the password. So it may be admin. Then automatically I have access to again your wireless network. In other words, I'm able to get free internet access. So you want to make sure, first of all, again, that you hide your SSID. Now, that's not going to prevent a hacker from finding it, because they still have tools where they can still be able to locate that. But that's the first step you can move toward securing that, again, that wireless router. Some other things that you can employ, again, with that wireless router, again, is make sure you use the latest technology. Like, for example, WPA2. If you're using WEP, which is antiquated and outdated, it's not secure at all. So again, you want to make sure you do that. You might also want to filter your devices by MAC addresses. You may ask, what do you mean by MAC addresses? Every computer has a different MAC address. So what you can do is you can actually join your computer to your network by virtue of the MAC addresses. And that's one way of adding another layer of security to your device. You can also set up some form of authentication server that goes through the authentication process before it allows you to access the wireless network. So let's mention a couple of things that you can do, again, from a security perspective to secure those wireless networks or wireless devices. Now, again, the SSID is a name for your wireless LAN. And again, a connecting host must know your SSID in order to be able to connect. We also have WEP, which again is an older type wireless encryption protocol, which is rapidly fell out of favor when it flawed with the encryption mechanism was found. Again, if you have a router and someone comes along and says, I'm going to give you a Class B router, one of the older routers, probably the only thing you're going to be able to configure is WEP technology. If you decide to employ WEP technology, just be aware of the fact that you're putting your information or whatever you're doing at risk by utilizing outdated technology that's no longer supported. Again, it makes it easier for someone who wants to engage in hacking activities, or perhaps who want to access your wireless network and get free internet access. There are a lot of, believe it or not, you have a lot of individuals who go out and purchase these wireless routers, and they're so happy, they're so thrilled about the fact that they got this new technology that they don't even think about securing a router. They just, hey, they're happy they got the ability to be mobile. So again, obviously as a future professional, IT professional as such, if you're viewing this particular video, you're going to make sure you're not going to engage in that type of activity. WPA, again, it was designed as an interim successor to WPE. Once they, WEP, in other words, once they found there were weaknesses to that, they developed WPA. Now we have WPA2, which stands for Wi-Fi Protected Access version 2. It's a standard-based version of WPA, except with WPA2, it implements all of the IEEE 802.11 type standards. Again, a MAC address, as I mentioned, is a unique hardware address, again, that's burnt into the network adapter. No two computers, nor or any device that employs a network interface card have the same exact MAC address. Again, by turning your MAC filtering on, your network access can be limited to only permitted systems by entering the MAC address information to the MAC filters.